Thank you very much for having me participate in this workshop. I'm sorry I'm unable to be there in person, but I look forward to telling you about this project. In this study, we examined several key sectors that are going to be very critical for Egypt's economic future. These sectors are water supplies, agriculture, coastal resources, tourism, and human health. And in human health, we looked both at heat stress as well as the effects of reduced air quality. So I want to also emphasize important key aspects of this study. Most importantly, this process was a collaboration between the research team and the Egyptian government as well as researchers in Egypt. We used estimates of change in water supply, crop yield, and inundation of the Nile Delta. These were done by the Egyptian government and reported on in the Second National Communication to the Framework Convention on Climate Change, and they also reflected research done by Egyptian researchers. In particular, I want to call out Dr. El Kanzouri and the Ministry of Water Resources and Irrigation, which played a very important role in this project. And then from these estimates, the research team developed estimates of economic impacts of climate change. This slide shows the structure of the study, and let me walk you through it quickly. The first row shows the scenarios of socioeconomic and climate change that we use. So the first box in the upper left is population scenarios. We got those from the Second National Communication, from Egypt's Second National Communication, and from the United Nations to extrapolate them out to the middle of the century. Socioeconomic scenarios are essentially scenarios of income growth. We got those from the Intergovernmental Panel on Climate Change, an optimistic and a pessimistic scenario. And then in the third box are the climate change scenarios. These acronyms are names of climate models that we use to reflect the wide range of potential change and flow of the Nile in particular. In the next row, we see the changes that in biophysical effects that we did not estimate. These were previously done studies. So the first box on the left is runoff in the Nile. This was done by Dr. El Shami of the MWRI, who, by the way, was also very helpful to us in carrying out this study in general. Crop yields came from the Second National Communication, and inundation in a delta was calculated by the Coastal Research Institute, Dr. El Shinaway in particular. Then in the third row, this is the new work we did. So water resources was estimated. This essentially is how much water was in the is actually in the Aswan Dam or flows into it, is estimated by Dr. Paul Kirshen of University of New Hampshire. Agriculture, which combined estimates of crop yields, loss of land from sea level rise, and available water. That was done by Dr. Bruce McCarl of Texas A&M University. And then in the third box, Dr. Mohammed Abdrabo of the University of Alexandria took the estimated loss of land and estimated the value of property, particularly houses and roads that would be lost. And then finally, in the fourth row, in the bottom left, two studies studies on human health and air quality, which as well as heat stress, which Dr. Leland Deck and I did. And then I looked at estimates of how tourism might be affected. All of these estimates were done in terms of Egyptian pounds. We assumed an exchange rate of 5.5 EGP per dollar. This was based on the exchange rate in early 2011, and then we took it from there. So now let me explain briefly the socioeconomic and climate scenarios we used in this project. This figure shows population scenarios used in the study, and it's based on assumptions from the Second National Communication. So there are two scenarios. The pessimistic one has population double by 2060. That assumes no change in fertility. The optimistic scenario assumes a very significant reduction in fertility and population stabilizing by about the middle of the century. These figures show what is projected to happen to Egyptian income, what we assumed in the study. The bar charts on the left show the total income measured in gross domestic product in Egyptian pounds, beginning with just under $1 trillion EGP in 2009, in the pessimistic scenario growing to $2 trillion by 2030 and about $6 trillion by 2060, the optimistic scenario having faster income growth, growing to $3 trillion in 2030 and over $9 trillion by 2060. The bar charts on the right show income per capita What is clearly evident is you see more of a difference between the optimistic and pessimistic scenario. That's because there's lower population growth in the optimistic scenario. So we get the pessimistic scenario. Even there, we get a tripling of income per capita up to 36,000 Egyptian pounds per person. But in the optimistic scenario, it goes up more than almost sevenfold to 82,000 Egyptian pounds by 2060. Here we see projections of our expenditures on tourism. The units are in millions of Egyptian pounds. We're not showing number of tourists, but how much money they're spending. And the bars on the left show actual data from 2004 to 2010. When we conducted the study, we did not have data in recent years, and I understand tourism levels have declined considerably, but hope that is just a temporary outcome. We assume there would be significant growth in tourist expenditures over the 21st century as tourists themselves there are more of them and they're wealthier. The way we got these projections is we first extrapolated from the 2004 to 2008 data. You see a steady increase in tourist expenditures, and those result in the red bars, the higher bars, which really are more optimistic projections. We also accounted for the entire data set, 2004 to 2010. There was a dip in tourism, presumably because of the global recession. We accounted for all that and extrapolated. We got slightly lower projections, but still significant increases. So by 2030, you see tourism expenditures around 200 billion Egyptian pounds a year. By 2060, they're in the range of almost 350 to almost 500 billion Egyptian pounds per year. Here we see the climate change scenarios, starting the top with scenarios for the Blue Nile Basin, essentially the source of the Nile. This was data provided by Dr. El-Shami. All three of these, again, these acronyms are climate models. All three of these models have an increase in temperature. The big difference is precipitation. So the top model has a decrease in precipitation, which creates, combined with the higher temperatures, a large decrease in flow. The middle model has a small increase in precipitation, but when we factor in temperature, we still get a small decrease in flow because of the effect of evaporation. And the bottom model, what is called MIROC, has a 14% increase in precipitation, which even though there is an increase in temperature, we get some increase in flow. And this is typical. Most models show a decrease in flow, but not all for the Nile. The bottom of this chart shows temperature and precipitation changes for Cairo. We took the same climate models and used a tool called SimClim to calculate this. In 2030, we see an increase of a degree of warming. By 2060, it's about 2 degrees, so more warming. You see 2 of the 3 models show a decrease in precipitation, more so in 2060 than 2030. This is consistent with what we expect to happen in the Mediterranean. Indeed, with what is already happening in the Mediterranean, it is getting hotter and drier. Where the Nile is, the source of the Nile further south, it's not as clear what the change in climate will be, and our scenarios reflect that. Here we see scenarios of sea level rise by 2060 in 3 locations, Port Said, Al-Barillas, and Alexandria. You'll notice substantial differences. What this is showing is the effect of global sea level rise, the global increase in sea level, as well as subsidence, because the Nile Delta is subsiding. And what really is most evident here is that you're getting much more sea level rise, relative sea level rise, in Port Said than the other 2 locations, because it is subsiding. There's much more subsidence there than the other 2 locations. The 3 bars reflect different scenarios of global sea level rise. These were used by Corey. They reflect projections by the Intergovernmental Panel on Climate Change in 2007. Since then, the science suggests that sea level may actually rise more than these scenarios suggest, possibly a lot more. So numbers could be even greater. But again, you see the effect of different levels of sea level rise as well as different rates of subsidence, anywhere from 10 centimeters to over a meter of relative sea level rise by 2060. Let's now look at the results. Here are the estimated changes in flow into the High Aswan Dam, one of the most important outcomes. So we start, Egypt's current allocation of Nile River water is 55.5 billion cubic meters, BCM. We assume that changes in estimated Nile flow then show up as changes in what's delivered to Egypt. In that high flow scenario, increased flow scenario, we get more water coming in, rising to 63, then 70 BCM by 2060, significant increase. In that middle scenario, the small decrease in flow, we get a small decrease by 2030, a few BCM. It's over 5 by 2060, more than 10%. In the large decrease, we see a decrease of about 20% by 2030, 10 BCM, and then a decrease of about 20 BCM by 2060, well over more than a third. So very significant, quite a wide range, and potentially very significant changes in the water available to Egypt. This figure shows land at risk from sea level rise in the Nile Delta. We drew it using data supplied by Corey. The blue area shows land that could be inundated if there is no protection from sea level rise. Now, this is the highest scenario that Corey used, but as I mentioned earlier, sea level rise could be even higher, so potentially even more land could be a risk. Now, this assumes no protection. If there is protection, much less land would be inundated, so a significantly small portion would be inundated. But it is interesting to see that that northeast sector in the Nile Delta appears to be the lowest lying and therefore the most vulnerable to sea level rise. Here we see the impacts of sea level rise on property in the Nile Delta. The chart above was calculated by Dr. Drabo and shows the number of homes that are at risk from sea level rise if there is no protection. And we see over 250,000 housing units at risk by 2030. By 2060, the number increases to also over 250,000 to as much as over 1 million. And again, the sea level rise could be even greater than what was assumed in this assessment. The bottom chart shows the value of those housing units along with roads that are at risk from sea level rise on an annual basis, not total basis. And it shows 1 to 2 billion Egyptian pounds per year in 2030. The value rises to 2 to 16 billion Egyptian pounds by 2060. The optimistic numbers are higher because value of houses are assumed to track income per capita, which is much higher under the optimistic scenario. Here we see changes in crop yields directly affected by climate change. These don't account for change in water supply, just the effects of temperature. And this is from the Egyptian Second National Communication. These are changes in 2060. If you look at that yield column, just glance down there, you'll see all negative numbers. All these crops are projected to have decreased yields with higher temperatures, except for cotton. That cotton benefits. Then if you look at the right-hand column, that's water use. Those are all positive numbers. All these crops will need more water, so we'd have less output, but more need for water. This information, along with the availability of water and change in arable land in the delta, was used in the agriculture analysis, which I'll now show. Here are the estimated impacts on agricultural production by 2030. Look in the row called production. We see decreases, even where there's more water, decrease output 4% to as much as 17% by 2030. If there's less production, prices will be higher. They do rise substantially, 13 to 38%. If there's higher prices, there's probably going to be less consumption. We see decreases of 3 to 8%. That probably means more malnutrition. And then finally, we see, at least in 2 of the 3 scenarios, decreases in labor hours, more unemployment, although it is interesting, in one of the scenarios, even though there's less production, there is actually more labor. By 2060, the impacts on agriculture are much more significant. Let's first look at production. Decreases of 8% in the high flow scenario, reduction of a quarter, 27% in the small flow reduction scenario. In the large flow reduction scenario, we have a decrease of almost half of agricultural production. That leads to very significant increases in prices, 16, 40% to as much as 70% in the worst case scenario. With those kind of increases in prices, we get significant reductions in food consumption, 5% to as much as 15 to as much as 30%. That would have to have a significant effect on malnutrition. And then finally look at labor hours. One scenario, they go up. The others, there are decreases in employment of 20 to 40%. Very significant changes. Now let's turn to what the economists call welfare, looking at the economic effects of change in agricultural production. We first look at the first line shows impacts on consumers. This is measured in billions of Egyptian pounds per year, not percentage changes. Losses of 30 to more than 60 billion Egyptian pounds to consumers. Producers gain. That seems odd because production is reduced, but that's because prices go up by a higher percentage and production is reduced. So those that are able to grow crops actually can get more income. Trade goes up slightly. The net effect, though, is negative. More harm to consumers than gain to producers, so we see a net effect of roughly 15 to 25 billion Egyptian pounds of loss per year. By 2060, we saw more negative impacts on agricultural production and therefore larger economic impacts. Look at the consumer losses, 70 to almost 300 billion Egyptian pounds in terms of negative effects on consumer welfare. Producers gain more than they did in 2030, but their gains are in tens of billions of Egyptian pounds. There is a slight increase in trade, probably because of increased value of cotton. But on net, there's a loss of 40 billion to over 100 to over 230 billion Egyptian pounds a year. Very significant impacts. Now let's turn to human health. First, looking at heat stress. More heat waves, we can expect more deaths. This analysis was done assuming that there's no increase in air conditioning or other measures. Now, if Egypt's income grows, we assume there probably would be more use of air conditioning. Nonetheless, the results are as follows. By 2030, we estimate, and this is just for Cairo, increases of several hundred deaths per year from heat stress. By 2060, it's several thousand. The difference being the purple is the pessimistic bar. That's because there are more people, much more population, therefore more deaths. Also, those people would be less wealthy, although that was not factored in here. The bars on the right are the estimated welfare loss. This uses something called the value of statistical life. It's what in the abstract society is willing to pay to save life. It's based a lot on income. So we see losses of a few billion Egyptian pounds by 2030. By 2060, they're measured in the tens of billions of Egyptian pounds. It is interesting, it's actually the optimistic case that has higher losses because even though population is a lot smaller, the per capita income is much higher than in the pessimistic case, and value of statistical life depends on that. So that's what drives that result. The impacts on tourism account both for just it being warmer and resorts, say maybe in southern Europe, becoming relatively more attractive than Egypt is, and also accounts for the effect of loss of coral reefs because of higher ocean temperatures and ocean acidity. Most of the loss, estimated loss here, is from the direct temperature effect based on work by European economists published in some leading journals. And so the losses to tourism, and this is not number of tourists, this is and expenditures, is tens of millions of Egyptian pounds by 2030. We estimated getting up to 100 billion Egyptian pounds by 2060. Very significant reductions in tourism. Air pollution is already a big issue in Cairo, and climate change could make it worse. What we did here was essentially a sensitivity analysis using expert judgment. We looked at a study of Phoenix, Arizona, also an inland desert city, and looked at what could happen there, and we assumed that particulate matter, which is very dangerous to human health, would increase by 1 microgram per meter, essentially a sensitivity analysis. This results in several hundred to several thousand additional deaths in 2030, somewhat more in 2060 because of population growth. Again, we were assuming no countermeasures. The value of that loss of life uses the same method we use for heat stress. We see billions of Egyptian pounds lost in 2030, billions to tens of billions of Egyptian pounds in terms of value of loss of life by 2060. And this does not account for morbidity effects, which are also very important. This graph shows loss by sector, agriculture clearly being the most affected, hundreds of billions of losses annually, up to several hundred billion. Tourism is next, and then the other sectors. What does this add up to? Here are the combined economic impacts for all the sectors we studied in 2030, showing first the individual sectors. Please look at the second line from the bottom, the total of selected impacts. These are in billions of Egyptian pounds in 2030. Here we're showing the two scenarios on the left are the pessimistic socioeconomic scenario, the two flow reduction scenarios. The one on the right is the optimistic socioeconomic scenario with a small reduction in flow. All three show losses of about 50 billion Egyptian pounds per year. The difference in percentages, which is shown on the bottom row, it's a slightly smaller percentage, under 2%, with a high economic growth, over 2% with a low economic growth. By 2060, the economic impacts are much higher. Again, the same scenarios here, same sectors. Look at the line from the bottom. 200 billion, roughly, in economic losses in the more optimistic scenario with optimistic economic growth. Over 200 billion with the pessimistic socioeconomic scenario, low reduction flow. Roughly 350 billion in annual losses when flow in the Nile is reduced significantly. In percentage terms, much worse than what we saw in 2030, about a little over 2% in the optimistic scenario on the right, but up to 4% in the middle scenario. That left scenario, which is the most pessimistic, we get up to 6% loss in GDP. Very significant reduction in GDP, much higher than many other countries are estimated to face, by the way. As significant as the estimated impacts are in Egypt, there are other effects that were not accounted for in the study, including other human health effects such as decrease in water quality, change in disease. We did not account for the full cost of sea level rise, either in terms of the total value of property at risk or in terms of what it would cost to defend the Nile Delta, places such as Alexandria. And then we didn't look at other natural resource impacts, particularly on fisheries, which may be very important, or biodiversity in general. In conclusion, I think what we show here are very significant economic risks for Egypt. Several percent of GDP. That is a lot. Big reduction in potential growth of the economy. Social risks we did not get into, but could be significant. Now, a reduction in greenhouse gas emissions, future emissions, would reduce some of these risks somewhat. That would take a pretty concerted effort, but it won't avoid all change. Even an aggressive greenhouse gas reduction program will not avoid all future climate change. Therefore, at least some of these impacts could happen. That means that adaptation is a necessity for Egypt. So thank you very much. I wish I could be there in person. I'd be happy to answer questions either now or through email later.